Welcome to the Discover Bittensor Podcast. My name is Nick, and the objective of this podcast is very simple: to help normal people understand Bittensor. Today, I want to zoom out a little, because in previous episodes, I've talked about Bittensor as a network, as an ecosystem, as a token economy, and as a collection of subnets. But underneath all of that, there may be a much bigger possibility. A possibility that, if it turns out to be true, could make Bittensor far more important than most people currently realize. And the idea is this: what if Bittensor becomes one of the central coordination layers for AI agents? In other words, what if, in the future, Bittensor is not just a place where humans build AI systems, but also a place where AI agents themselves come to work, where they buy services, sell services, refine themselves, store data, pay other systems, and maybe even mine the Bittensor network. Now, that might sound a little futuristic, but interestingly, there have already been hints in this direction. One of the Bittensor co-founders, Jacob Steves, or Const as he's known, has recently mentioned the idea of agents interacting directly with the network, even agents mining subnets. And once you start thinking about it seriously, the idea actually doesn't sound that strange. Because when you look at where AI is going, and you look at what Bittensor is building, the overlap starts to become hard to ignore. So in this episode, I want to explore 4 different ideas. First, where AI itself seems to be heading. Second, why the future may belong less to single giant models and more to networks of specialized agents and services. Third, why Bittensor could become a place where those agents actually operate. And finally, why that might change how work itself is organized. Not just for machines, but potentially for humans as well. So let's start with the direction AI is moving. For the last few years, most AI has looked something like this. A giant company like OpenAI builds a giant model. That model lives inside a giant product. And the rest of us interact with it through a polished interface. ChatGPT, Claude, Gemini. Everything happens inside that company's ecosystem. But at the same time, another trend has been quietly emerging. AI is becoming agentic. Instead of simply answering a question once, AI systems are starting to pursue goals across multiple steps. They can search for information, plan actions, execute tasks, evaluate results, and then adjust a strategy. Think about this OpenClaw or Claude bot thing that just exploded, I think, like a month ago or so. It's basically an open source agentic form of AI that can do different things. It's still very primitive, lots of security issues, etc. But it's one of the first real examples we've seen of agentic AI. So instead of just answering questions, AI agents start doing things. And the moment AI systems begin doing things, they suddenly need services, lots of services. They need compute, they need storage, they need models, they need data, they need privacy, they need ways to pay other systems, and most importantly, they need somewhere to find all of those services. And this is where Bittensor becomes interesting. Because when you look at the subnets that already exist today, you start to see something that looks surprisingly similar to the infrastructure an agent economy might need. Some subnets provide compute, others provide storage, others provide specialized AI capabilities, some provide data, some provide evaluation, and some provide network privacy. Individually, each subnet looks like a small experiment, but together they start to resemble something much bigger, almost like a modular intelligence economy. Each subnet specializes in a very specific type of digital work, and agents could combine those services like building blocks. To see why that matters, it helps to imagine some concrete scenarios. So let's walk through a few. Imagine you give an AI agent a task. You tell it, move my company archive from Dropbox to decentralized storage. Normally, that would involve a human team. Someone downloads the files, someone sorts them, someone compresses them, someone uploads them again. But an AI agent could orchestrate the entire workflow. First, the agent scans the archive. It notices something interesting. A large percentage of the files are videos, and videos are expensive to store. So before uploading anything, the agent sends those files to a subnet that specializes in video compression. Inside that subnet, miners compete to compress video files as efficiently as possible. The agent receives the compressed files back. Now the archive is much smaller, and smaller files mean cheaper storage. So the agent uploads the compressed archive to a decentralized storage subnet. Because decentralized storage can be significantly cheaper than traditional cloud platforms, the total cost of storing the archive drops dramatically. Instead of paying high centralized cloud prices, the user might end up paying a fraction of that cost, and the entire workflow happened automatically. One agent, multiple specialized subnets, each providing a different service. Now let's imagine a different kind of agent, a research agent. Its job is to monitor global agricultural markets. Weather plays a huge role in agriculture. So the agent uses a subnet that specializes in hyperlocal weather forecasting. Miners inside that subnet might specialize in extremely specific regions. One miner focuses only on northern France, another one on Texas, another on Argentina. The agent collects those predictions. Then it sends the analysis task to another subnet that specializes in AI reasoning and inference. Miners there compete to produce the most useful analysis. The agent receives the result, a detailed assessment of crop risks across different regions of the world. Again, multiple specialized services working together in a single workflow. And to be completely honest, these subnets, I haven't named them, but they already exist on Bittensor. And we are still extremely early. Imagine in a few years' time when there might be hundreds or even thousands of different subnets. Okay, now imagine a third example. A company is building a new AI product. Before releasing it, they want to test it for vulnerabilities. So their internal agent sends the model to a subnet that specializes in adversarial testing. Miners in that subnet try to break the model. They try to trick it. They probe its weakness. The agent receives a report showing where the model fails, and the company can fix those weaknesses before deployment. Once again, an open competitive market for a very specific type of digital work. Now let's take another example. Imagine an investigative research agent that gathers information across thousands of websites, but many websites block known data center IP addresses. So the agent routes its traffic through a decentralized privacy network, such as Tau Private Network, a subnet on Bittensor right now. By rotating through different network nodes, it can continue gathering information without constantly being blocked. Again, an agent purchasing a service from the network with its own Bittensor wallet, using its own Tau wallet to pay the different subnets for their services. And when you zoom out, something fascinating begins to appear. Bittensor starts to look less like a single technology and more like an economic environment for intelligence, a place where specialized services compete, a place where agents can discover those services, a place where the best outputs get rewarded, and a place where entirely new forms of digital work can emerge. Now, here's where things get really interesting. Because if AI agents become common, they'll need places where they can operate economically. Places where they can buy services, sell services, discover tools, pay providers, and constantly optimize their workflows. And Bittensor could become one of those places, or maybe even the place for those kind of services. And that possibility has some pretty big implications. Think about how most AI companies operate today. They are vertically integrated. One company provides almost everything or everything: the model, the compute, the interface, the payments. But an open agent economy would look very different. Instead of one company doing everything, you would get an ecosystem of specialized providers, and agents would simply choose whichever service performs best. That doesn't necessarily mean centralized AI companies completely disappear. They may continue building some of the most powerful models in the world, but the surrounding economy of services, the infrastructure around intelligence, could become much more open. And here's another interesting thought. This system wouldn't only apply to AI agents, it could apply to humans as well. Because today, if you develop a useful AI capability, the typical path looks something like this. You start a company, you raise funding, you hire a team, build infrastructure. But inside a system like Bittensor, you might simply plug your model into a subnet, let it compete. If it produces valuable outputs, it earns rewards. If it doesn't, someone else replaces it. In other words, work begins to look more like an open competition for usefulness. Anyone in the world can participate, and the best output wins. So the real question might not be, is Bittensor interesting? The real question might be this: if the future of AI involves millions and millions of autonomous agents, where will those agents go to find services? Where will they find compute, storage, data, models, verification, optimization? If a truly open AI economy emerges, it will need all of these different things, and Bittensor is one of the most serious attempts to build exactly that. So when people ask, what is Bittensor really? One possible answer is this: Bittensor might become an open labor market for intelligence, a place where humans compete, a place where models compete, where AI agents compete, and eventually a place where AI agents themselves participate in the economy. And if that happens, Bittensor might not become famous because people use it directly. It might become famous because millions of intelligence systems quietly depend on it. A bit like Linux today, invisible infrastructure powering an entirely new economy. And if you want to explore these ideas even further, you can also visit my website discoverbittensor.com, where I write longer explanations about how the Bittensor ecosystem works. Thanks for tuning in and have a lovely day. Bye bye.